Let's discuss the next topic in the syllabus, which is called sets. So the topic for the session is sets. What is a set? We have discussed about different sets. The word set has been most commonly used in mathematics in many of the topics. But what is a set? Before we start this topic, let's take some real life examples. When I just write, say for example, in the previous case, we have taken the natural numbers as 1, 2, 3, 4, 5, and so on and so forth. I said n is set of natural numbers. So what is the word set when I have considered the case of natural numbers? Is what derives the topic of the session. So a set is the collection of numbers. As I can clearly see here with n, the set of natural numbers is the collection of the numbers 1, 2, 3, 4, 5, so on and so forth till infinity. So I understand that if I collect some objects and put that in this symbol form, then the flower brackets, which we call them as flower brackets, then that forms a set. But there is a more mathematical, meaningful definition for a set when we enter more further into understanding a set. So let's see what are the two restrictions which limit the defining of a set. So firstly, when I go with the definition, my first limitation is that all the elements or objects considered must be related to each other. So they must be related to each other. Say for example, I take a geometric box. When I take the mathematical geometry box and I include a compass, a protractor, a ruler, an eraser, that's it. So these are the things which form a well-defined collection because all the elements are related to each other when I just have a geometric box. Even a pencil can be inside the geometry box. But when I include a watch inside the geometry box, then I don't say that the watch is related to the geometry box. Is how I understand the first limitation. For example, when I take the geometry box, instrumental box, then I have a pen, a pencil, an eraser, a compass, ruler, protractor. They're all part of the geometrical instrument box, which we use in construction of geometrical figures. So these are related to each other. So when they are written in set form, definitely form a well-defined collection of objects. Therefore, the first property which defines that the elements or objects which are considered must be related are very much related here. But say for example, if I include a wristwatch into this, may not form a well-defined collection of objects because a wristwatch inside the geometry box may not be a good idea because that they are very different and not related to each other. If we understand in the sense of geometrical instruments, a wristwatch is nowhere related to the geometrical instruments. Hence, inclusion of wristwatch inside the set of all these objects may not form a set. But excluding this, these objects or elements might form a set. So this makes us clear understanding on the objects considered must be related to each other. Secondly, when I pick the objects, I should be able to pick the objects inside the set. The objects or elements inside the set or elements should be able to be picked. picked up. So when I say the objects or elements should be able to be picked up, then this forms a very complex situation, because when I take the example of stars in the sky may not form a set, because it is very difficult to pick the different stars in the sky. There are infinitely many stars, so picking up of stars in the sky may not be a set, based on the second limitation of which states that the objects or elements should be able to be picked up. For example, stars in the sky may not form a set. So this doesn't form a set. But when I pick vowels from English alphabets, the vowels definitely can be picked from the 26 letters of the English alphabets, starting from A and ending with Z. But when I take the example of vowels of English alphabets can easily be picked, therefore the vowels form a set, the stars in the sky do not form a set. The instruments in the geometry box form a set, but when a wristwatch is included in the geometry box, does not form a set, supported with the limitation 1 and the limitation 2. So vowels of English alphabets, which are clearly A, E, I, O, U, is something which we already know in the English class. The vowels are A, E, I, O, U, forms a set of vowels of English alphabets, the 26 letters starting from A to Z. So with this clear picture, it makes me understand that a set is a well-defined collection of objects. So when I go with the definition, it says that a well-defined collection of objects is called a set. So here the two examples make us understand on what is a set and what is not a set. So let's see some more examples on deciding whether a given condition is a set or not a set. So for example, I start with few of the examples. To start with, set of all odd positive integers. So let me start with set of all positive integers. So it is a well-defined collection because I can pick the odd positive integers and they are very much related to each other. So let's see set of all positive odd integers. If I take this in the form of O 1, 3, 5, 7, 9 and so on and so forth forms the set of all odd positive integers, and this is very much a set. So let's take another example of set of all collection of all good students in the class. So this has to be decided on two different conditions. Students in the class are very much related because they are in one class, but when I say about good students, I think it is not easy to pick up who is good and who is bad. Judging of good and bad has various factors affecting the justification of good and bad. Therefore, collection of all good students in the class may not be a set because it is difficult to identify the good students exactly on mathematical grounds. Therefore, the collection of all good students in the class may not be a set because it is not well defined. This is not well defined, and therefore this doesn't form a set, but this forms a set because it is a well defined collection of objects. Now let me take an interesting example which we are going to connect with sets and also with presumed knowledge on prime numbers. So with an example, write the set of all even primes is my question. I want to write the set of all even primes. Now primes are very much related to each other because they don't have factors other than 1 and itself. Now I had to find the set of all even primes. So the answer would be definitely it is a set because it is a well-defined collection of objects and we can pick up the even primes out of all the numbers existing in real number system. So this is a set, but I want to find the set of all even primes. The answer for this set would be that there is only one even prime which we identify in the real number system, and that is 2. Therefore, this is the set consisting of only one element, that is 2. So the answer for this would be singleton 2 because we are going to discuss about what this kind of a set is called in the future classes. But the answer is set of all even primes. There's only one even prime in mathematics, and that is 2, which is the least prime.